Okay, welcome everybody. Is this week 12? I think this is week 12. All right, as suggested slash promised, I would like to spend today and possibly next week talking about live coding. So live coding is a creative practice that I guess you can describe it as blending composition, improvisation, and performance, and with digital real-time tools. It's just a way of making music, and in some cases other media. There's live coding for visuals and stuff like that. But the unifying descriptor is that you are creating the art in real time. And I would even go so far as to say there's a requirement that when you are performing with live coding, you have to show your screen. You have to project your screen, and everyone has to see what you're doing, and it's even sort of one step further than just improvisation on an instrument. You're actually sort of building the instrument in real time as you are playing it, like sort of assembling some. Anyway, it's not, full disclaimer, I am not a seasoned, experienced practitioner of live coding. I sort of know some things. I try to get my practice in. I'm trying to get better, but it's it's not something I've studied extensively. So I just don't want to give the impression that I'm some sort of expert. So I'd like to just kind of go through the ropes and give you a sense of the basic mechanisms of live coding in SuperCollider. And I should also say there are other front-end languages, like Tidal Cycles is one which is popular, and Foxdot, Sonic Pi. These are things I haven't really used myself. I've just sort of seen people use them every now and then. And the language and syntax is different. But I believe all or most of them use the SuperCollider synthesis engine as the back-end audio engine. So SuperCollider has its own quirks and language and syntax and stuff. So it's depending on the type of music you make. There might be an interface out there which is maybe better. But SuperCollider certainly stands on its own as a platform that allows you to do live coding. So let me start by contextualizing live coding by presenting it as a sort of problem. And the problem is if you are making sound in SuperCollider using the usual methods that we've covered over the course of the semester, which is like, maybe you want to just, I don't know, play like a binaural sine wave. Right? And so there we go, we have a sound. And in live coding, basically you make sound and you start manipulating that sound and adding other sounds and mixing it with other sounds. And so if we want to change this sound, what are our options here? We don't have any arguments. We have a name, X, but I mean, really, what can we do? I mean, if we were to go here and say, okay, well, let's make this, up to 300 hertz, and we run this, we've created another one. Maybe we wanted to change the first one, and now we have two sound processes. They're both contained in the language side variable X, and so if we want to get rid of this one, then the other one is not really addressable, and so we have to do something clunky and awkward. So the core of the problem is that in live coding, it's an improvisation, and the whole idea is that you're not planning all your moves in advance. You want to be nimble. You want to be able to dynamically execute some musical decision that pops into your head. And with our current knowledge of SuperCollider, we can't really do that without planning ahead. So that's kind of the problem, and the solution comes to us in the form of a library of classes called JITLib, JITLib, which is short for just-in-time library. So it's a family of classes which are designed to solve this problem, which allow you to create sound processes dynamically, play them, fade them in, fade them out, change their parameters without interruption, without all this sort of baggage of having to manage variable names and things like that. And in, I think there's a couple of tutorials. If you scroll down just a little bit, there's a sequence of 4 tutorials on which I've based this lecture, and this lecture is also based on how I've written the last chapter in my book. So it's, what we'll talk about and the order in which we'll talk about it is kind of a combination of both things. But these are good resources, full of interesting examples that explain what we're dealing with and then how we actually get things done. So one of the central classes in JITLib is NodeProxy. So NodeProxy is a type of proxy object. And generally speaking, in the context of SuperCollider, a proxy is described as a placeholder for something. It allows us to work with information which may not be fully concretely defined and in existence. So it's like, basically you have some process and you want to say, let's play this process. I'll tell you what it sounds like later. And the JITLib and NodeProxy says, okay, I'm playing. I'm currently empty. I have nothing to play, but I'm playing. And then you can fill in the details later. It's a little bit like trying to say what is x plus 2? Well, okay, we can't do that yet because we don't know what x is. But if we say the function, let's see, what's the right word? X plus 2. This is actually allowed. And the idea is that SuperCollider knows what a function is, and it doesn't need to look inside to do operations with it. It says, okay, I can't give you a concrete result right now, but I have no problem performing this action. So if we say like store, let's say, I think this is going to work. If we say y equals this expression, it doesn't have a number. We don't know what value it is. But if we later say, I might be doing this wrong actually, but okay, yeah. So now it actually works. Yeah, once we've given x a value, we can then we can actually get the result. So this is like a very simple example of what NodeProxy does. It lets us play a sound before it actually knows what that sound is. Okay, so let's see how that works. We're going to create a new NodeProxy object. And this is sort of how it looks by default. We've just created a new one, and it exists. And we can say, is this NodeProxy playing? No, it's not. But we can play it. And then once we do that, is playing returns true. And we'll even look at the node tree here. And some stuff has happened. Okay? So we have our node tree. And I'm gonna get rid of this NodeProxy by just clearing it. So this is like the hardest possible deletion. This is like, it's gone, it doesn't exist, it never existed, all of its attributes have been reset. The only thing that remains is that n is still technically a NodeProxy, but it's been completely cleared. So when we play this NodeProxy again, the back end of JITLib creates 2 groups. One up here, which is basically where the source of the proxy itself lives. And then down here, we have a pair of stereo monitoring objects. These are the synthesis processes that are responsible for taking the output of the proxy and connecting it to hardware buses. So this separation is nice because we can have a proxy which is playing and has a definition, but we can manipulate this monitor section in case we don't want to hear it. We'll come back to this, but this is what we have so far. We've created a NodeProxy and we've played it. And it's playing, but it doesn't have a source. In fact, we can look at the source, and the source is nil. Okay? But what we can do then is say, well, let's set the source to be some valid ugen function. There's two syntaxes we can use here. We can say n.source equals some function. Let's do it this way. Right? So we're just going to set the source equal to just the thing that we would normally do without the .play, because we're already playing the NodeProxy. It's already playing. So as soon as we do this, right, we have sound. And now we can make any sort of changes. Normally I would just delete and overwrite this because I'm trying to record this lecture. We're going to do it on separate lines. But in live coding, you wouldn't actually write it out multiple times. So here, right, we can divide the frequency by 2. And we can start adding on to this. Right. Do a little polyrhythm thing. We can go back here if we want. This is not musically very interesting, but you can, I mean, obviously we've solved the problem, and just by introducing play and source and clear. So let's clear it again. Now this will just remove it immediately, but clear takes fade time in seconds. So we can do this, and you can see we've got our source here, and it's fading it out. And the monitor, so then the whole proxy architecture disappears.
So what was the number 6?
This is just seconds. 6 seconds is the duration over which the clearing process will take. So it fades it out, and then at the end of that 6 seconds, it's at 0, and then it clears it.
So that NodeProxy doesn't exist anymore at all.
Right, so if we try to play it now,
There is no
the source has been reset to nil. So clear is like I'm definitely done with this. Let's get it out of here, right? But now we're playing again, and so now we can, make a new source. That's interesting. It doesn't sound like a sawtooth wave. It sounds like a triangle wave. Well, anyway, it's all right. I don't want to get too distracted here. Right? Let's just fade it out over 1 second. Okay, that is like the bare bones introduction to NodeProxy. So let me introduce the next key feature here, which is the fade time. Okay. We play our NodeProxy. And this is one syntax. We just set the source equal to a function. We can do our underscore syntax as well with parentheses. And let's do something like this. Maybe we'll filter it. Actually, before we filter it, I'd like to have this change happen quickly, because if we just do it like this, and then kind of happens immediately, and we want the flexibility to make things change over a period of time. So we can set every NodeProxy has a fade time, and the default for audio rate NodeProxys is 0.02 seconds. It's very short. Not instantaneous, just long enough that it doesn't like happen with an ugly click. So we can set this to be whatever we want. We'll say 3 seconds. And so we've set that attribute, and now we can go back here and change this filter parameter. Increase the amplitude. So every change involves the creation of a new proxy source node in the upper group, while the other one fades away. So they both have this fade. It's a crossfade essentially. And I should also mention that if you don't want to clear a NodeProxy, but you do want it to go silent, you have a couple of different options. One is to just set it to the empty function. That's the same thing as it not having a source in the first place. You can always bring it back, it's still playing. And there's a few other methods that are useful for stopping and starting and things like that. So we've already seen play, and what play does is it creates the source node, which is this one here in the top group here. We can say n.stop, and that's a hard stop, and you can see it made the, I have to back up. The play and stop, those are associated with the monitor objects in the bottom group. I was wrong a second ago. I spoke too quickly. So the play and stop create and destroy the monitoring objects, which again are the part of the NodeProxy infrastructure that connects the source signal to hardware. So if we hit play again, it comes back on. Right? And when we set the source function, we're dealing with stuff up here, but we can also manipulate the monitoring object. We access it with n.monitor, and that's a monitor object. And we can this monitor has its own fade time, which is nothing. But if we set this to 1, for example, then if we stop, the monitor object is faded out over 1 second, and the play also respects. So play and stop are actually talking to the monitor object, and we can give it a fade time if we want to. Think of this like just your main volume knob, and you're just turning it down, turning it up. And now the fade time of the NodeProxy is 3. I'm going to make this 5 for emphasis. And now if we say n.release, this is like the equivalent of stop, but it applies to the proxy object. So we're the actual source of the sound, and we can n.send to reinstantiate that object. And send doesn't just turn it back on. It's not just a volume thing. It actually reevaluates the function again. So as an example, what I'll do here is change the source. See, right now it's still sounding like this. So we just faded one out and faded one back in. But let's say there was some randomness involved here. Let me say rand 40, 80. Well, no, let's do, here's what we're going to do. 60 times, I'm very indecisive today. Sorry. We'll say, actually, rand negative 2.0, positive 2.0 dot MIDI ratio. Okay, so every time we change the source, this random thing is happening again and again. I'm going to make this a larger range just for... Yeah, this is not a dynamic noise generator. This is a it just picks a random number once when the process is activated. But so if we release, yeah, this basically fades out the proxy source. And sending it doesn't just turn it back on, but it actually it's like saying this is your source again. Like it actually runs and processes that code and creates the UGen graph function that determines what it sounds like. And even you can just run send again and again, and this will just reevaluate. This is no different from just running the source line again and again without changing it. Yeah, you just want the proxy source to reevaluate itself. So. And then there is also pause and resume. These are the ones that, maybe there's a way to do fade times here, but this is just like, you can see it doesn't even go away. This is actually, there in the list of done actions, we know 0 is do nothing, 2 is free the synth, 1 is pause the synth. So that's basically what we're doing here, it keeps it alive on the server but stops calculating, and it just sort of freezes it in time. And so here we can make changes, like we can just double the frequency or something, and change the source, but it's still paused. So when we bring it back in, now it's got that higher frequency. But for sound processes, you generally don't want to just disrupt them like that. It's kind of against the not really what we want to do. Yeah, what I usually find myself doing is just kind of creating a couple of proxy objects, defining their sources, and kind of manipulating those sources. And you can do kind of a lot of interesting stuff, even with just like 2 or 3 independent NodeProxy objects. Let's just make another one just to show you. Make a little crackly thing here. Yeah. Yeah, and then we might turn this one down even more, just filter it even more aggressively. Change this up a little bit. Let's see, I'm trying to remember. Release follows the proxy's fade time, so this should just be 5 seconds. Yeah. Okay, just getting marginally more musically interesting here. It is, I just to pause here, I'm hoping to kind of teach you the basics of like the mechanisms and how to talk to these JITLib objects, but I don't know if it's possible to I mean, like, how do you teach improvisation? It can be taught, but then when push comes to shove and you're on stage, I mean, there's no script to follow, there's no score to read. This is kind of a creative process of discovery that you kind of have to experience on your own. And I think as everyone kind of gets their hands dirty with live coding, you will find that you gravitate towards a little bag of tricks and things which sound good and which you can type quickly and which will work and which are relatively risk-free. And you'll probably see my own bag of tricks as I do this. But, so that is all right. So we've covered NodeProxy, play, fade time, source, setting, play and stop, send and release, pause and resume, and clear. So at this point, I would like to talk about 3 different paradigms that that are available for us to access JITLib objects, and NodeProxy is one of them. And this is probably the least used of the 3. This is, I think this is probably the most typing, just having to type a lot of stuff. Well, okay, so I'll just get right into it. There's another object called Ndef. which is a subclass of NodeProxy, encapsulates all of its methods. I don't know if it adds too many of its own. Ultimately, you can just look at Ndef as a stylistic alternative, and it follows the same structural, like syntax structure as like synthdef, mididef, and those kinds of objects. So I still have some things over here, so I think I just need to do m.clear and n.clear just to.
I have a good question.
Yes.
Can you have those two inside parentheses and clear them at the same time?
Oh, you mean like well, let's so you're saying if you have two ndefs and you want to just clear them both at the same time?
I just wonder if that's possible.
Like you were to do like m comma n dot clear or something. I don't think.
Or like having those both processes happen at the same time within parentheses and evaluate that.
Yeah. So if you want to clear all of them at the same time, with NodeProxy, I think you basically have to have them stored in a collection and iterate over that collection. Maybe there's another way to do it, but the way I would do it is m comma n dot do, something like this.
If we literally just put like a parentheses
Exactly.
before, like on line 76, if we just put an open parentheses.
Oh, yes, of course. Oh, I'm sorry. Yeah, you don't have to. Yeah, you can just evaluate.
Oh,
No
okay.
proxy.
That's totally. Well, I played them by accident, but I meant to put these in parentheses. Right.
Exactly.
Of course.
Okay, perfect.
Yeah. This.
That applies also to a no proxy.
You can always.
Like exploding and stuff.
Yeah. You can always evaluate multiple lines of code at the same time. There's never. Yeah. No. You can clear two things simultaneously for sure. But you'll see with Ndef and the other option, which is ProxySpace, there are more elegant options for dealing with all. So Ndef is really just like a syntactical substitute. We're not changing too much, but let me just show you how it works. So the main benefit of Ndef is that we don't have to deal with language side interpreter or environment variables like n and m, because like with NodeProxy, if we were to do n equals NodeProxy dot new and then run let's see, and play it, right? If we do this and then do it again, we actually create another NodeProxy object, and they're both stored. So we have the same problem that we saw earlier of just running this twice. So NodeProxy trusts us to like manage our variables so that we can talk to these things appropriately. So we have to, I think, just command period here, just to just wipe them all away, right? They're gone. We'll just ignore them. So Ndef avoids this problem because it's like with a synthdef named sign, you can create it, and then if you make another one with the same name, it just replaces the old one. So it basically uses this backend identity dictionary, which ensures that you can't have two things with the same name. So we say Ndef, we give a symbol. Yeah, and so we can say Ndef n dot play, Ndef n dot fade time is going to be 3, and then we don't have to say dot source here. We just use the Ndef and then follow it up with a function right in here. Yeah, it says a lot of people like Ndef. I think this is a good one. So we'll do signask. And there we go. And then we just, and I think it's good to maybe put this in a chunk like this so that in case you want to start, being a little bit more formal with what you're writing, you can, and we'll do, what did I do wrong? There we go. So just kind of improvising a little bit, right? And you can clear it. I believe play and stop and send release all work the same way. And the benefit here is that you don't have to worry about accidentally making another Ndef that somehow lives side by side and steals its name. Every time you run this, it just the actual content lives at the same location and just replaces the previous one. So no need for language side variables here. Right, okay. And then ProxySpace is the third option. So let me see, this one will be ProxySpace. And this one requires a little bit more explanation. Okay, so ProxySpace is not actually the object. It's not like a third option that's used instead of Ndef. ProxySpace actually defines a special type of environment in which the node proxies will live. Okay, so to start this discussion, consider, for example, our environment variables. Like we have A equals 3, B equals 7. And we know if we tab over to a new document, we can still use these. They make sense everywhere. Technically, these are environment variables, but we often call them global variables because they seem to have global scope. But they don't really have global scope. They are scoped based on the environment which is currently active. And we usually don't have any need to change the current environment, but it is possible. There's a special keyword, current environment, which returns our current environment and all of the objects that are stored in it. You can see we have A and B. And we can make our own environment like this, and then we push this environment so that it becomes the frontmost or topmost environment. And now if we check current environment, it's empty. And so we can say, A equals 19, B equals 104. And now if we say current environment, here we are, okay? Because we're in E, we're not in the default environment. We've made our own environment, and so it's a way of having these different containers with lots of different information. And if we want to leave E, we pop. And now if we check current environment, we're back to our original one, okay? So push and pop, I think it's fun to draw a picture here. I think of the way environments are stored, it's like they live in a box, like a little square box or something. Okay, and when we launch SuperCollider, we have a little square, it's like, think of it as a little square plate, right? That kind of gets dropped into the top of the box, and the topmost, this little plate is our environment, right? And then when we create an environment and we push, you can think of this box as being kind of like spring-loaded, and this E comes on top of the current environment and basically presses it down. So this one here is our old one, and then E has been pushed onto the top, so then E is on the top. And so whatever the topmost one, that's our current environment. And when we pop, we hit a little lever, and it goes kasproing, and that one pops out, and the one right below it takes its place, and we're back where we started. So you can keep pushing environments, and then you just pop them out, and whichever one was below it is the one that you have left. I'm not really sure, but there's probably a good reason why the storage mechanism is here, instead of just saying, make this one active, make this one active. But I don't really know what it is, but this is how it works. So you basically, you still have this environment, and you can just, push it again, and then, we've got 19 and 104. But then whenever you don't want it, you just pop it out of the stack, and then you're back to our first one. Yes?
I have a question.
Okay.
If you now create a new one, let's say D is a new environment.
Yeah.
Push that one.
Yeah.
We were already on E. So
I think we were actually back on the first one.
Oh, the default. Okay.
Right.
So
Okay. But that's fine. So this one, we'll put something in D,
exactly.
just so we can actually see, right? And so now what we're going to do is pop D, right? And now we're back to our original one, the default one that SuperCollider gives us. So your question is, what if we like?
What if we accumulate them?
Oh yeah, okay. So we push E, and now we're in E, which has these things in it. And then if we push D, then D is now the top of the stack. And so if we want to get back to this one, we have to pop D and then pop E. I'm not actually sure what happens if you do them in the wrong order, but certainly if you pop D, pop E, then we're back here.
So it literally accumulates.
Yeah, it just adds more to the top of the stack, and you pop them off. Yeah. Okay. So why am I talking about all this? Like, ProxySpace is a type of environment. Its superclass is something called lazy environment, I guess. We don't really care about that. So ProxySpace is a special type of environment. So you can push and pop just like a regular environment, except when a ProxySpace is the current environment, every environment variable, that is everything that starts with a tilde, is a node proxy. So it's sort of a different way of thinking. So let's p equals ProxySpace.new, and you can also attach a server and a clock to a ProxySpace. So you can say S to say your server. It's always going to be S unless you're doing some sort of networked performance or something. And clock is for timing and quantization. We're not quite there yet. We'll get there. You can even, like, if the server is not on, you can boot the server, and this s.boot returns the server. So this is all fine, and you can push it. So you can kind of do it all in one go. Make a ProxySpace, attach it to the server, boot the server, and push the environment, and it'll boot the server, and our current environment is a ProxySpace, and it's empty. Okay. So now, if we just say something as simple as X, and we just run this line, it's already a node proxy. It's not nil, right? It's actually a node proxy. Its rate is nil. Its number of channels is nil. It doesn't have any information, but nevertheless, we can play it. And once we play it, it says, oh, you must want an audio rate proxy since you're playing this. And I'm going to assume you want 2 channels because that's pretty normal. So there's a bunch of decisions that Ndef and NodeProxy do this too. If you play a NodeProxy or an Ndef and don't tell it how many channels you want, it's going to say, I'm just going to give you 2 because that seems reasonable. So now to set the source or the fade time, we just do it like we normally would with our underscore setter or equals, and we don't have to say dot source. We just say set it equal to. Just trying to come up with interesting sounds here, and there's only so much I can do without killing a bunch of time. But let's do. And I messed something up. Do we need that? Yeah. We have our fade time, so. So this is we're inside of a ProxySpace, and I think that I like ProxySpace the best. I think it's the least amount of typing, and it feels the most elegant to me. The problem with ProxySpace is that, let's say you want to load a sound file in or something like that. So it's okay, we'll do b equals buffer.read. So there is a solution. Don't panic just yet. Let's see. Let's just get a. One of these here, copy this in. So we're just trying to load a sample in, and it says, whoa, hang on there, cowboy. That's not a valid source for a node proxy. A buffer? No, I can't do that. So all environment variables have to be node proxy, so they have to follow node proxy rules. but we still have our interpreter variables, okay? But don't be fooled, we don't have just 26 of them, because they can be anything. They don't have to be singular things. Okay, we shouldn't use S, because S is the server, but we'll just say A, I don't know, you pick whatever letter you want, and make it an empty event, okay? So A is now this empty event, and we can say A dot, flute 0 equals this buffer. And that's totally fine. You can just dump stuff into this event using a unique key, and you can use this method syntax if you want. And so then we can, interesting. Oh, sorry, yeah, not the event, this thing, right? And so then we can say, make a, we'll just do this, and we'll say play buff. Is this one channel? It's 2 channels, okay. 2 channels, a.fl0. Make the rate down there, and we can, and yeah, I don't think did I do this? I can't remember. We might have to, I think, it's because it's got a fade time of 3, but we're just playing the buffer once. So it basically plays it as it's fading in. We'll fix that by just re-triggering it a bunch of times. Oh, sorry, I didn't mean to do that. I meant to do that. Okay, so we can do buffers. We can, just anything we want to keep track of, we can just use a single event and then just, create sub-events if we need, So this event can be arbitrarily large. You could, like if you just want like a set of pitches or something like that, you can say a dot pitches equals this other, I don't know. You can make it, you get the idea, right? I mean, you can structure this. This is just like a big flexible data structure, which isn't the NodeProxy, doesn't have to follow NodeProxy rules, but the event, just having collections within collections within collections, that's my workaround. There might be others, but this one works well enough for me. It's just taking advantage of these juicy interpreter variables, which thank goodness they exist, because it'd be a lot more difficult without them. Okay. That, I guess, is where we'll stop for today. I think with just what we've covered today, you can do interesting stuff, right? Just make a bunch of independent node proxies in whatever of the 3 paradigms feels best to you, and set their fade times, and then just start playing around with parameters. And I like to quote one of the tutorials that in Sonic Pi that Sam Aaron has written, where he says that in live coding there's no mistakes, only opportunities. Which, yeah. So if I were to assign a homework on live coding, I would want you to sort of hit 5 minutes and just at some point have 3 simultaneous things going, and just start with silence, end with silence, and just everything else is just fair game. And trust me when I say when the nose to the grindstone, 5 minutes flies by. You're gonna be barely getting started and be like, oh, that was 5 minutes, So there's a lot of live coding performances out there which are tend to be kind of slow to get started and even slow to progress. And I think it's fair to say that the sort of slow-moving ambient textural thing is a nice fit for live coding. But people do rhythmic stuff too. We haven't gotten to clocks and quantization. So, but the next thing we'll do next week is routing and patching, and sort of taking one node proxy and feeding it into another one. like having effects and source proxies, and it's really nice because having just recently talked about groups and add actions and order of execution, all of this stuff is handled automatically. So it will automatically rearrange stuff to give you the correct order, if you know. So it's very handy. And yeah, well, good. I'm glad you think it's exciting. That makes me happy.
I dream to be able to improvise
Yeah.
like this.
So do I. I also dream to be able
That's a
to
dream that I want to
improvise with live coding.
Hopefully in a couple of years.
Yeah.
be able to.
It really is like playing an instrument. You just have to sit down and practice and like listen to other people's live coding and study, and you know, but everyone can get there. So.
You know what I will be able to do eventually? Like have like a microphone that I can also record myself and stuff live,
Oh yeah.
and like create, you know, like my piece last semester, create like a lot of like textual stuff with own voice,
Yeah.
human voice, and
Yeah.
through singing.
Have we talked about sound in this class? Yeah. So that's
Yeah, sound in, exactly. Yeah, we
yeah.
talked about it. Yeah.
And yeah, so if you're making a node proxy and you could just put sound in there, and it's just listening to your microphone, and you can manipulate that signal however you want. And
I was going to ask actually that if this course we're going to go over like live processing of like recording and then do the process like at the same time.
yeah, like if we could do that. Yeah, I mean, I was thinking about just kind of doing a little informal poll. I mean, if there's topics that you want to cover.
I'm so interested.
Yeah. Okay. Well, with the topic of like processing a live microphone, it's important to emphasize that it's not really any different from the stuff that we've already been doing. It's all signal processing. It doesn't matter if it's a sine wave or a noise generator or a microphone signal. It's all the same. It's all just digital audio. And so anything you want to do, and then like in the book, there's like delay and reverb and live granular effects at the end of chapter, I think, 6, I think. At the end of chapter 6, it just goes over some of the, you know, ways of constructing real-time effects. And those are all kind of big-ish synth-defs. I don't know if they make the most sense for live coding because it is kind of a lot of typing. But yeah, we'll do a little bit of that. Maybe I'll just process this microphone signal that I have here on my collar. And we'll just, yeah, and we'll combine it with live coding, and you know, we'll just play around. Okay, good. That's it for this week, and we'll do more live coding stuff, maybe some live processing of mic signals next week.